Hello everyone, and welcome to today's video. Today we will be doing an introduction on Lens, the Kubernetes IDE. A Kubernetes IDE that allows you to take full situational awareness of all things that are happening within your Kubernetes cluster. Lens is 100% open source and free, and we recommend visiting our website to get started. Before we begin, I would like to ask each and every single one of you to please like and subscribe to our channel as we post new videos every single week. As we all know, Kubernetes is quite complex and challenging. You have to leverage many different technologies, resources, and documentation to begin your journey on Kubernetes and container initiatives. Many team members, organizations, and individuals do not see the return on investment with their Kubernetes initiatives that they would like to see. This is where Lens comes in. Lens is a 100% open source, free desktop application built for all of your Kubernetes needs. It allows users to easily onboard and operate their applications in Kubernetes to improve time to market, productivity, and increasing return on investment. Lens, the Kubernetes IDE, is a one-stop desktop application that allows you to achieve full situational awareness when working with Kubernetes. It's perfect for developers who push proprietary code and need to observe that code, deploy the code, test it, and of course, troubleshoot it within their Kubernetes service. Lens is fantastic for Kubernetes site reliability engineers and operators, individuals that need to understand the health and status of their Kubernetes cluster, the real-time events, lifecycle management, and of course, the ability to troubleshoot and configure all in real time. Lens is the world's most popular Kubernetes IDE. With over 250,000 active users, Lens is by far the most popular Kubernetes IDE. Lens provides our users with complete situational awareness of all things Kubernetes, regardless if you're working on an on-prem cluster or with a public cloud. It works with any certified Kubernetes distro, from Minikube all the way down to EKS, K0s, and K3s. As long as that Kubernetes distro is certified, you can deploy that cluster directly to your desktop application. Lens was designed for two categories of people: individuals that are just getting started with Kubernetes, and people that are experts with Kubernetes. It radically improves productivity and the quality of life for somebody that leverages Kubernetes on a day-to-day basis. Let's take a look at some of the most exciting features within Lens. The unified catalog should be thought of as your cloud-native directory, where you can bring clusters, services, workloads, and tools into one beautiful place that gives you the ability to filter, search, and categorize these different resources. Lens Hotbars is the main navigation of Lens. Hotbars allows you to build specific workflows and automations on your desktop application when working with Kubernetes. Lens leverages a pre-built-in Prometheus. This allows our users to very easily understand how their cluster is performing in the last hour, from the CPU to the memory, the network, and the file system. Lens gives our users a granular view into each and every single Kubernetes object within their Kubernetes cluster, all in real time. The Smart Terminal was built for people that need to manage multiple Kubernetes clusters at once. Switching from cluster to cluster, Lens automatically connects to the correct cluster API endpoint, meaning if I switch from a Minikube cluster to a K0s cluster, I'm always maintaining the correct Kubernetes cluster endpoint. This is going to allow me to work much more efficiently when leveraging multiple Kubernetes clusters, production-grade clusters, deployment clusters, proof of concept clusters, and so forth. I can switch from cluster to cluster while always maintaining the correct Kubernetes cluster API endpoint. Lens comes with Helm charts as well. Easily search and manage between thousands of different clusters all in real time. Lens allows our users to install Helm charts directly to your cluster, all in real time in the matter of seconds. Lens has extensions too. Extensions are built by community members and partners that want to leverage our user base. Organizations can build extensions on top of Lens where they can leverage our user base. For example, you can build an extension that will show you vulnerabilities within your Kubernetes cluster, or an extension that shows how all of your Kubernetes resources are related to one another within your Kubernetes cluster. Spaces. Lens Spaces is a centralized cloud-based offering that allows our users to very easily create secure spaces where they can add Kubernetes clusters to. This means I can very easily share access to a Kubernetes cluster with a colleague all in real time. If I have a cluster that needs debugging, or I have a developer that needs to see our microservices within a Kubernetes cluster, I can share access to that Kubernetes cluster through Lens very easily. This was a quick introduction into Lens the IDE. Today we'll be taking a look at how to install Lens the Kubernetes IDE. You'll want to access your web browser and go to khlens.dev. Once again, that is khlens.dev. I do want to mention that Lens is 100% open source and free, and it is a desktop application built for your Kubernetes needs. Once on the website, it's quite simple. Download for your correct operating system from Mac, Windows, and Linux. Simply click download, and Lens will begin downloading in your operating system. Once downloaded, you can very easily open Lens and add a cluster. Now that you've downloaded Lens, the desktop application, you want to launch the application, add a cluster to the application, view the settings of your cluster, and we'll want to remove the cluster as well. To do so, let's launch the application. Now that we're launching Lens, this will be the home screen that you see. There are two ways to add a cluster to Lens. The first is the easiest way. Click Browse Clusters in your catalog. Once you click this button, Lens will actually begin searching for a kubeconfig file directly on your operating system. As you can see, Lens has found a Minikube cluster on my operating system. From here, we'll want to open this Minikube cluster, click to open, and our cluster is now on our desktop application. We can see how our cluster is performing in the last hour through the pre-built-in Prometheus, from the CPU to the memory. There's another way you can add a cluster directly to Lens, and this is more of a manual way. To do so, we'll click File and Add Cluster. Once we're within this screen, you'll actually just copy and paste your kubeconfig file directly into this terminal and click Add Cluster. This will add your cluster manually to Lens the desktop application. From here, let's actually view the settings of our cluster. We can give our cluster a name, Edwards Performance Cluster, and we can give our cluster an icon. Let's use this screenshot. Now that we've given our cluster a name and an icon, there's several things we can do. We can view namespaces, we can add a new namespace, we can view our metrics. We can go to Lens metrics down here and actually pre-install Lens Prometheus or Prometheus directly onto our cluster. This is going to give us that beautiful visualization of how our cluster is performing in the last hour. And as we can see on the left-hand side, we can see the icon and the name of our cluster. This is going to help us work much more efficiently when working with multiple Kubernetes clusters. When working with multiple Kubernetes clusters, Lens actually has a pre-built-in smart terminal, meaning it always matches to the correct cluster endpoint. So if I'm working with multiple Kubernetes clusters and I switch from cluster to cluster, I can be ensured that the terminal is always matched to the correct Kubernetes cluster API endpoint, as we can see here. This is going to allow us to work much more efficiently when working with multiple Kubernetes clusters. Closing out of our terminal, we can go to our overview screen. Within our overview screen, we have several different functions we can perform. We can view our pods, our deployments, our daemon sets, and so forth. Going back to our pods, we actually have the ability to view a much more granular view of how this particular pod is performing in the last hour through the pre-built-in Prometheus that we installed directly to our cluster, from the CPU to the memory, the network, and of course the file system. Dependent on your role-based access control, there's various different administrative functions you can perform to your cluster or the different objects within it. You can attach to the pod, you can shell into the pod, you can view the logs, and you can make configuration changes to that pod if you choose to do so by clicking the edit button. Now we can make configuration changes to this particular resource. As you can see, Lens gives us the ability to understand how our cluster is performing all in real time in the last hour through the pre-built-in Prometheus. We receive warning messages that tell us exactly which Kubernetes resource is associated to this warning message. This is going to help us troubleshoot and debug when working with multiple Kubernetes clusters or just one, as we can see here. Going back to our pods, our deployments, we can always see how our cluster is performing and the objects within it. I also want to mention that Lens allows us to actually create resources directly into our Kubernetes clusters, and we have some pre-built-in resources as well. For example, I can deploy an Nginx deployment directly to my cluster withoat having to write any kubectl. Simply click Create and Close, and we'll create that Nginx deployment. From here, we can click this Nginx deployment. We can see when it was created 5 seconds ago. We can see the name, the namespace, and all of the annotations and labels that are associated to it as well. Through Kubernetes and Lens's user interface, we can actually scale this deployment up or down while leveraging Kubernetes. Now I'm scaling it, and we begin creating these containers. Now they're all running. If I go to pods, we can see all of these different pods are successfully running. If I want to scale it down, again, we'll leverage Kubernetes, click the scale icon, and scale this down. So we took a look at several things. Launching Lens, adding a cluster manually, viewing the settings of our cluster, and of course, leveraging Lens's beautiful user interface to do specific permissions and functions. Now let's remove our cluster from Lens. Simply right-click on the hotbar and click Delete. This is going to delete our kubeconfig file directly from Lens. We now have no more clusters on Lens desktop application. Now that we've added our cluster to Lens desktop application and viewed the settings, let's go ahead and deploy a Helm chart directly to our Kubernetes cluster. Let's go back to our cluster by clicking Clusters in our catalog, clicking Minikube, and opening this cluster. We have now opened that cluster directly into Lens, and as demonstrated before, we can see how our cluster is performing in the last hour through the pre-built-in Prometheus. From here, you'll have the ability to choose which repos you would like to see within your desktop application. Select Lens, Preferences, Kubernetes, and scroll down. Here, you can choose from thousands of different publicly made repos and add them directly to Lens. If I start selecting these repos, HeroCube, Aerospike, we can see these repos are being added to Lens. There are thousands to choose from. We'll click one more, Armory. And from here, we'll actually want to exit the screen and go view which Helm charts can be deployed to our cluster. We'll click Escape. We'll navigate down to this section called Apps and click Charts. This is where you'll find all of the Helm charts that are made available via the repos you've selected. As we can see, the Aerospike, the Armory, Bitnami, Mirantis, Conduction, and so forth. So here are all of the repos and the Helm charts that are associated to each repo. From here, we'll want to search for the Helm chart we care about the most. For demonstration purposes, We can deploy a Cassandra. We can view the details of this Helm chart. All of the links that are associated. Anything hyperlinked within Lens is clickable. So if I click this, it'll automatically launch a browser, as we can see here, and it gives us an introduction. Navigating back to Lens, all we have to do to install this Helm chart is click Install. We can open this window a little bigger, see all the details, and we'll click Install one more time. Now this Helm chart will be installed directly to our cluster, as we can see. But we'll want to take a look at what resources were deployed to our Kubernetes cluster. So we'll click View Helm Release. And this is where we can make configuration changes if we choose to do so. But now, when we scroll down, we can see all resources that were deployed directly into our Kubernetes cluster. The service account, the secrets, the service, and of course the stateful sets. Clicking into this service account, we're immediately given the detail screen of what is happening, from the labels to the annotations, and of course the namespace it's associated with. We can edit and make configuration changes to this particular object if we choose to do so. Navigating back to our releases, we can always view in this releases section, within the application section, what Helm charts are deployed to our Kubernetes cluster. Again, we'll open this. It may take a moment. We'll scroll down, and again, we can see everything that's associated. So I'll click the stateful set, we'll open it, and I'm immediately given a granular view of this stateful set, the Cassandra set, from the CPU to the memory, the network, and the file system. We can see when it was created 70 seconds ago, the name, the namespace it's associated with, and the labels. Lens allows users to very easily install and deploy Helm charts directly to their Kubernetes cluster. We'll take a look at Lens extensions. There are over 100 extensions currently available on top of Lens, and 15 of them are publicly made. To view extensions, it's quite simple. We'll click Lens on the top left screen, Extensions, and we'll be brought to a screen where we can install an extension on top of our desktop application. First, we'll want to take a look at which extensions are publicly made available. Clicking Available Extensions will automatically launch the publicly made extensions that are vetted by Team Lens. There are several extensions that user can choose from. The Mirantis Container Cloud extension by Mirantis that allows you to very easily add a MCC cluster directly to Lens. A Starboard extension by Aqua Security, which gives our users the ability to see vulnerability reports on their Kubernetes clusters, and many more. In order to get started with an extension, it's quite simple. You want to install that extension. We'll install the resource map. We'll go to Releases. And we'll actually install this extension directly to our operating system. Once installed, we'll navigate back to Lens, search for that installation, that extension. We'll click on it, and I believe it's this one actually. Yep. And we'll use this configuration. We'll install it. We uninstall it because I already had it, and then we installed a new one so we can see. Now that this extension is installed, to view this extension, it's quite simple. We'll close out of the screen, scroll to the bottom, and click Resource Map. All extensions are at the bottom of our navigation. Clicking Resource Map will actually launch the extension. Resource Map is the name of this extension. This extension is quite cool. It's actually developed by Team Lens, and it shows us how all of our Kubernetes objects and resources are related to one another. Hovering over one of these, you can immediately see the details of this particular object and resource. You can click into it, and it immediately gives you that granular view that we're also aware of within Lens, the desktop application. As mentioned, there's hundreds of different extensions currently available, many of them being private, but 15 publicly made extensions that anybody can leverage. I do want to note that users and organizations within the cloud native ecosystem have the ability to create any extension and leverage our user base. Navigating back to Lens and clicking Extensions, we'll click Check out Docs, and this is where you can find out how to build a Lens extension. Everything is in one beautiful place. Going back to Lens, clicking Escape. It looks like our Minikube cluster timed out. That's fine. We'll reconnect. May take a moment. See what's going on. Perfect. And we're back to our cluster. All extensions live at the bottom, and you can very easily leverage these extensions. This is my favorite extension that allows us to understand how our resources are related to one another. We'll be taking a look at Lens Spaces. Lens Spaces is a centralized cloud-based offering provided by Team Lens on top of Lens IDE, the desktop application, that allows our users to securely share access to Kubernetes clusters with their colleagues from anywhere to anyone, all in real time, very easily. To get started, you'll have to create a user account. The reason for this, again, is because Lens Spaces is a centralized cloud-based offering on top of Lens, the open source IDE. Meaning to access this feature, we'll have to create an account. To do so, you'll need Lens 5 at the bare minimum to be downloaded. So go to Lens, click About Lens, and ensure that you're leveraging at least Lens 5. Here we can see I'm leveraging Lens 5.13. From here, you're going to want to log into Lens. To do so, you click Lens Login. It's immediately going to open your browser and direct you to Lens Spaces signup. There's several ways you can do so. You can sign up via GitHub, Google, and you can create an account. Because I already have an account, I'm just going to log in. And in just a moment, I'll be logged into my Lens Spaces account. And Lens, the desktop application, can see that I'm now logged in on the bottom right-hand side of your screen. Now that I'm logged in, let's browse our clusters in our catalog. We'll take a look at our clusters. We'll open them. We'll take a look at my GKE cluster and, of course, my Minikube cluster. We'll launch these clusters and connect them to Lens, the desktop application. We can see how this cluster is performing, the nodes that are associated to, right? The settings, if we choose to do so, and so forth. In order to share one of these clusters with a team member or colleague or anyone that needs access to this cluster, I'll need to create a space. There's several ways you can create a space. You can navigate to your catalog, scroll down to Spaces, and hit the plus icon, and this will automatically allow you to create a space very, very easily. Or you can navigate to your username on the bottom right-hand side of your screen and click Add Space. The space I'm going to create is going to be called Code Cloud Demo 1, and I'll click Enter. We have now created a space called Code Cloud Demo 1. From here, there's several things I can do. I can jump into the settings of this space and make some configuration changes if I choose to do so. For example, I can give it a display name, Developer Clusters. Let's say that this space is only meant for my developers, right? So every cluster within this space are for developers. We can give it a description. Clusters in this space are specific to developers. We can update the profile. Our profile has been updated. We can choose a image if we want, and so forth. From here, I'm actually going to invite a member to my space. The reason we need to invite a member to our space is this is going to allow them to have secure access to whatever lives within that space. Currently, the only thing supported are Kubernetes clusters, meaning if I invite a member to this space and I share a Kubernetes cluster to that space, they'll have access to that Kubernetes cluster. There's several ways you can invite a member to your space. You can invite them by username or email, or you can invite them with a direct access link by clicking the icon I just did. I'm not going to invite them via link. I'm actually going to invite a dummy account via username. To do so, you'll type in their username or email. This one is Tester Edward. Yes, this is a dummy account that I created. And I'll click Enter. The invite has been sent to my dummy account, and now they will be able to accept the invite and actually have access to whatever lives within this space. Currently, if we select this space, Code Cloud Demo 1, nothing lives within this space. To be able to add a Kubernetes cluster securely to Code Cloud Demo 1, I'll navigate to my Kubernetes clusters, and for this use case, I'll use my Minikube cluster, and I'll click the Share Cluster icon on the top right-hand side of the screen. Clicking this icon immediately gives me the ability to choose which space I would like to add my Kubernetes cluster to. For demonstration purposes, we'll add it to the space that I just created, which is Code Cloud Demo 1. I'll click this, and then we'll install Cluster Connect and share the Kubernetes cluster to our space. Cluster Connect is quite simple. It's the technology that allows us to securely share access to a Kubernetes cluster with our colleagues. Long story short, it combines a client-side reverse proxy and WebSocket tunnels and an end-to-end encryption to expose your Kubernetes API to the users. Meaning, it creates a secure tunnel from our user's desktop computer to the Kubernetes API. I think that's quite important to know. And it creates that end-to-end encryption, and the daemon set, the Cluster Connect, the boarded daemon, never sees the traffic that it's tunneling. It's absolutely encrypted, and it creates that secure tunnel from the user's desktop to the Kubernetes API. You can learn more about Cluster Connect and boarded by clicking this link here, which will immediately launch our Cluster Connect documentation page, where you can read and review the architecture of how Cluster Connect is industry secure. It meets all industry standards to ensure that sharing Kubernetes clusters with this space are secure. Excellent. From here, we're actually going to click Install Cluster Connect and Share. And once this is done, we've actually now shared our Minikube Kubernetes cluster to our Lens space, which is Code Cloud Demo 1. So now anybody that has access to that space, Code Cloud Demo 1, will be able to have access to our Kubernetes cluster. I do want to note that access is read-only, and individuals can create specific teams within the space to give much more granular access to that Kubernetes cluster. To do so, what you would do is you would go to Catalog, navigate back to your space, Code Cloud Demo 1, open it, go to Teams, and you'd create a team. You'd create a team maybe called Developers, and from here, you can go into the role binding and give specific access to this developer team to your Kubernetes cluster. Meaning, if I want my developer team to only have access to the monitoring namespace, I can do so. Excellent. From here, now that we've shared our cluster to our space, we're going to log out of my account and log into my demo account, my dummy account Lens space. We'll log out. We can immediately see that cluster is gone now, right? The Lens space's Minikube cluster. We can see the source is only local, and we no longer have that Lens space's Minikube cluster. We're going to click Lens Login. We'll be navigated back to that Lens Login screen. I'll log into my dummy account. We'll navigate back to our desktop application, and we can see we're logged into Tester Edward, in the bottom right-hand side on the screen. We can also see that we have some spaces here, only one, which is the Tester Edward space. But we do know that we've been invited to a space, and to be able to view the invitation to the space, we'll go to Tester Edward, we'll click My Profile, we'll navigate down to Spaces, and we can see that we've been invited to Code Cloud Demo 1. Navigating back to our clusters, I want to make this apparent. We can only see two clusters here. We can see the GKE cluster and the Minikube cluster. Both sources are local, right? And this is because they are on my desktop, on my computer, and they're connected to my desktop application Lens IDE. Now, navigating back to my profile and the spaces I've been invited to, I'm going to accept this invitation. And now I can see two spaces. There's the tester Edward default space, and then there's the clusters code cloud demo space, right? Clusters in this space is specific to developers. I'll close this. And now within our cluster screen, we can see 3 clusters. Earlier, we only saw 2 when I did not accept the invitation, meaning I could see my GKE clusters very easily. I can see my Minikube cluster, and now I see a 3rd cluster, which the space is lens spaces, and the spaces associated to is code cloud demo 1. Clicking on this, it's going to open up the cluster that was shared with me via the code cloud demo 1 space directly to my desktop application. Meaning if I'm a developer that needs access to a Kubernetes cluster to review the microservices, I can get access from a colleague, a team member, a cluster administrator via lens spaces. So I do not need to utilize kubeconfig files, VPNs, work behind firewalls and NATs, and really jump through all of these security risks that there is when sharing access to a Kubernetes cluster. Lens takes care of all of this for us. Lens Spaces does this in a very secure fashion, leveraging specific technologies that we can feel proud and ensured that our cluster is secure. So this is Lens Spaces. Again, it's a centralized cloud-based offering on top of Lens IDE, the desktop application, that allows us to securely share Kubernetes clusters with team members and colleagues securely. Thanks for taking the time to watch our video on Introduction to Lens, the Kubernetes IDE. We hope you enjoyed the video, and please let us know what you think of the tool in the comments below. As always, please like and subscribe to our channel as we post new videos every single week.